Hi. Yeah, I'm seeing one message from Shivani. Is there any way I can clear my doubt apart from the meet? Because yeah, okay. Yeah, means actually now I wanted to just I'm thinking that I will take some feedback from you and according to that one start this session. So it will be nice that you people can give how your study is going on as well as how you are feeling that course. Hello, people. Am I audible? People can just confirm if I'm audible. I can.
Yes, you're audible.
Yeah. Okay. So, okay, let's start. Let me introduce myself. I'm Jijit. I'm a PhD student of Indian Institute of Technology, Madras. I'm an interdisciplinary PhD student. I'm actually a physics person. Yeah, now doing interdisciplinary PhD in chemistry and biotechnology. Yeah. Actually, I did this course in my last semester, not last semester, last year. And I felt this course is very, very good. It's a it will give it's a good course such that it will give much more idea about how optics works. That's it. So hopefully you people also enjoying the course. I think most of them have covered at least 2 weeks lectures. Yeah, my prime idea is here to discuss with you. It's like that way. The main thing, this authorities have told me that okay, you people can solve some problems like similar problems such that it will be helpful for you to solve assignments as well as to write this examinations. So for that one, actually, I am feeling that it is better to take some feedback from you people, such that how it is going, what are the difficulties you are feeling, or whether you are enjoying the course, as well as whether these are actually recorded sessions, such that during the course actually you cannot ask questions. So it is better to do with the, like that way. There is one more TA who is for this course, such that we both will be answering your doubts and other things. So actually you can interact actually now. Nobody want to interact.
Hello.
Yeah,
Yeah, the course is, I would say, pretty well designed and clearing some basic doubts also. I'll say it is starting from base, so it is helping us to understand, like, yeah, how it is going and everything.
yeah, you can just tell what are the basic doubts you are having, if you don't mind.
Okay, I had some doubt in the first week assignment
Uh, the
for the
thing,
last problem.
okay, one minute. One thing I can say, that I cannot directly tell about assignment problems, because
Yeah,
that, yeah,
definitely.
date is still pending. I think day after tomorrow is your submission date.
Yeah, correct.
Yeah, but the thing is like that way. Today I am thinking, you may have tried this your week zero assignments, whether you may have tried.
Yes.
Yeah, today I am planning to go through that questions, and along with that one we will see what are the variations are. Actually, we will go through the questions, and we will see what are the things we can extract through that one. I feel that will be helpful for to do the assignments till two assignments two. That I'm feeling like that way. In between you can ask a question also. Means if you are having like a other than direct assignment question, you can ask directly now. I'll feel that whether it will be covered in this session, then I can directly tell that.
Okay. So can you tell me what books are recommended for the assignments?
Actually, as I go through this one, actually, which is, can you just tell that what is your background?
I am from MSc Physics.
Okay, so yeah, you may having some background regarding optics and other things.
Not actually, that's why.
No, no,
This
no.
is new to me.
That's not at all required. Because I am also a physics student. I am just saying that at least plus two you are having that. Plus two, some basics.
Yeah,
Not
the
don't don't
basics.
don't not at all think about you don't know. That's the thing. These are simple course, and
Mhm.
yeah, because I did my MSc physics only. I did my MSc from IIT Madras only.
Okay.
And even though, so I know that when some people think that if you don't understand how badly they will feel. So don't worry about anything. Don't think about you don't know any basics and thing. These things are this course is actually starting from very basic. So you don't worry about anything. So that you don't have to worry. You can ask any questions. So my point is that at least is some point. This will be like a, I don't know who people are joined here, but the course taken by the people will be like a very big spectrum, starting from like UG students to this big faculties also. So so my idea is like if I can explain something that should be understandable by everybody, that is the my motto. So if I can clear your doubt, I will be happy with that one. So don't worry about the standard of the doubt, or you whether you are knowing already something or not, nothing about like that. So you can ask anything. So it will be better. Yeah, it is nice that if you can give some feedback, you can just ask also. That such that I can start the session.
Hi,
Hi, thank you.
yeah, this is Kavita from Bangalore.
Yeah, Kavita, tell me.
Hello, can
Yeah,
you,
yeah,
can you,
yeah, yeah, I'm here.
yeah. So my question is like, in this, this one, we are dealing with Oslo,
Hmm.
right?
Yes, yes.
So nowadays in the industry, there are like other softwares like, Zmax is popular. So is there any other like is there any chances that we can work with Zmax in the this one in the course?
The course, I think this course is actually structured with the Oslo only. The thing is that it is dealing with the almost all spectrum. But I
Okay.
think, yeah, by learning these things, how to use and other things, I think you can use any software afterwards. It will be helpful.
Okay. Okay. Thank you.
Uh, can we start with the assignment zero problems? I hope so. It will be nice that if you people can talk. Now it's not like a large number of people are not at all here. Only 10 members I'm seeing. So it will be nice you can interact such that I can also feel how it is going on. Because when I am starting presenting in this Google Meet, you people may be knowing that I cannot see anything other than the what I am presenting. So it will be nice that I am hearing some voices. Hi, can I start?
Yes, please.
Okay. So let's start from actually assignment zero problems. Okay, I'll share my entire screen here. That's that you will also see. You may have tried assignment zero problem, na? Whether everybody tried or not?
I think we tried.
Yeah.
Yeah. But it was like kind of you know I personally I did not know much of these questions, so I just guessed few of them. So after started watching videos, I could do assignment 1,
Mm.
except one question I have a doubt, which may I may ask it later when
Okay.
we discuss about assignment 1.
Okay.
Yeah.
So yeah, this this assignment zero problem I am dealing in such a way that we are just will not mention that answer and go. We will just go through the how that cost answer is arrived. What are the things which we can get from that details? Like that we are going. So in between whatever you are doubt having, you just ask me. Okay, let us start. You people are seeing the screen, na? Now it will be nice that I will get some feedback as voice because I cannot see anything other than this presentation. So at least one person can interact. I will be happy that if more people are interacting.
Yes, we can see.
Okay. So
Yeah.
let's start with the first question. The first question will be simple. I think people may be knowing, and if people does not know also, we can go through the question. The unit of power of the lens is called. I think most of them will be knowing this one. The answer I can tell, or if you want to tell, you tell.
Diopter.
Yeah, the unit of the power of the lens is called diopter. Diopter is the power. What is mean by the power of a lens actually? That's the first thing. What are the, let's see that what are the information which we can get from that question. What is mean by the power of a lens?
It is 1 divided by f.
Yeah, that's a definition.
Yes.
What is exactly meaning? you know that yeah, 1 divided by f means we already know that okay, some lens can focus the ray which is coming through, passes through that one. So that is called focus, and that particular point is called focus, and the distance from the lens to that particular point is called the focal length, and the reciprocal of the focal length is called power. Right?
Yes.
Yeah. Now see what is mean by physical meaning of the power. It is like it is the ability of the light to bend.
Yeah.
So if the lens has the more power means it can bend the light in a steeper manner. That's the thing. So
Yes. So the curvature of the lens will be increased.
yeah. So the dependence.
So, hmm,
Yeah.
as the curvature of lens increases, it bends the light more and the focal length will be decreased.
Yeah.
Yes. So that increases the power of the lens.
Yes. So
Okay.
and now we can see that what is actually SI unit of the power. What is meant by diopter? Diopter is a name given to that one, but you may be knowing that there are like different like fundamental units and derived units. In that one, you may not have heard this diopter at all. What is actually the diopter?
SI unit of power is watt.
What? Oh no
Yeah.
no 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 no, not that power. Sorry sorry.
Diopter is nothing but measurement.
Diopter is nothing about. You can directly derive as a unit of the power. That name is like power means whatever I mean. Power is lens power only. Sorry.
Okay.
Uh,
Unit of
uh,
like power of lens.
yeah yeah yeah.
Okay.
Diopter is the name given to a. This is similar only, but you can just tell in terms of the fundamental units. It is nothing but a meter inverse. The meter inverse quantity is called diopter. Okay, one diopter means a 1 meter inverse or per meter.
Yes.
Okay, so if you know some lenses, okay, you are seeing this my screen. If you are seeing a lens will be two different types of lenses. You know, there are some lenses which can converge the light which is passing through it. Sorry. If parallel rays are coming, the lens can actually converge, or some another lenses are there in which
Divergent.
yeah, can diverge the rays, which is if the parallel rays are coming, it can diverge that. And it feels like it is coming from a point. Okay, you know this thing,
Yes.
and this distance is called the distance between the lens to that converging point.
Is the focal length.
Yeah, the length is called the focal length, and the converging point is called the focus.
Focal point. Yeah.
Similar way, in the case of a diverging lens, I am not saying anything like a concave, convex, or something. I am just telling diverging. So, because of this nature of this curvature, this can be like a concave, plano concave, double concave, plano convex, double convex, like different types it can form. That's why I'm just mentioning converging as well as diverging. Diverging. Okay. In the case of a diverging lens, there will be a point, there will be a virtual point from which we will feel that the rays are originating. Actually, the rays are Parallel rays are diverging and going away from the each other, but so we will feel that it is actually coming from one at a particular point. So that point is called focus of a diverging lens, and the distance between the focus to the lens is called focal length of that diverging lens. So for a converging lens, the focal length will be positive. For a diverging lens, focal length will be negative. Similar way, the power is nothing but a, what is P is equal to 1 by F, you can write. So it is like the inverse of the focal length. So for a converging lens, focal length will be, power will be positive, and a negative for a diverging lens. Now let's have some examples. I am saying that one a lens, I have a converging lens which have a focal length of 10 centimeter. I have a converging lens having a focal length of 10 centimeter. What will be its power? Anybody can tell?
0.1 diopter.
0.1 diopter. How you got that one?
1 divided by like focal length is 10 centimeter.
Okay, 1 divided by 10 you took. So
Yeah.
you got a 0.1. Let's see whether it's correct or not. Anybody have any other answer?
So it should be in meter. First, we have to convert 10 centimeter into meter, then 1 by
Yeah,
F.
yeah. So diopter, I already defined that it is a meter inverse.
Meter per inverse. Okay.
So first, what you have to convert, this 10 centimeter should be, you have to define in meter. 10 centimeter will be equal to how much meter?
0.1.
It will be 0.1 meter. So power will be 1 by 0.1. It will be
10.
it will be 10 diopter. Okay. So these are the things you have to understand while doing problems. You cannot directly take it because the question can contain like a focal length of the lens can be like a millimeter. Like you can see that your mobile camera have a lenses having a very small focal length. That means it's have a very high power actually.
Yes.
But yeah, you cannot just tell that if they are giving a 10 millimeter, or sometimes they can give like a power focal length like a very 2 or 3 meter. Original telescopes will have like a 2 or 3 meter focal length lenses. So you have to be in a standardized manner such that first you have to convert the focal length in SI. That means meter. Then you take the reciprocal. Then you will get a power in diopter. Okay. So that is the thing you have to take care. Okay. Now let us, in this thing, any questions are there? That first assignment, one question. So these are the things which you are, these are the things which we can go through. This much information we'll get from that first question itself. So if there is no question, I will go to the second question. Now see, from the first question, we will move to the second question. Consider a thin lens with a focal length as 10 centimeter. Which of the following statement is or are correct? Now, what are the information they given? They given a thin lens and it's having a focal length of plus 10 centimeter. Okay, which are the following statements is or are is correct? That is the thing. Now, see. Now, with that information, a thin lens of having focal length 10 centimeter. Let us see what is that. What is meant by a thin lens actually? Anybody can tell?
Thickness will be tending towards 0.
Yeah. So actually, it is a impossible task to make a lens of zero thickness, but we will think that the whole distances which is dealing with the lens is much less compared with the thickness of the lens. Like this focal length of the lens, or it is the distance which we are dealing with the lens are if much less compared with the thickness of the lens, we can consider the thickness of the lens as zero. So that kind of lens we are thinking as a thin lens. What is actually the requirement of the thin lens? You know, that is making our lives much more simpler. Actually, this we don't need to much discuss much more here, because the thick lens and thin lenses difference will come your consecutive lectures. So you will know much more about the thick lens on the coming lectures. Okay, now we can just deal with a thin lens. So what we are having is a thin lens having a focal length of plus 10 centimeter. Now you know plus 10 centimeter. What is that means? It is a what kind of lens?
It's a convex lens.
Yeah, it's a convex lens or it's a converging lens, I can say. Okay, it can be sometimes plano convex or concave or convex. It depends on the matter, but it's a converging lens. It will produce a positive focal length. So since most of them are familiar with the drawing is very bad.
Always.
And drawing a convex, double convex lens. Only two for familiarization. Now you people already deal with know that there will be an optical axis, and this will be converge the parallel rays which is coming from here to a point called a focus, and that particular point is called a focus. And if parallel rays are coming towards this lens, the thing is like that way. As per these details given by them, it's like that way. It will focus it to a point, and the distance will be 10 centimeter. This is the information which is given by the question. Now we can see. Then you can tell what are the things correct. Now you see. If a collimated beam passes through its lens, it will diverge. Whether it will diverge, whether it's true or false.
False.
Yeah. What it will do, since it is given as the plus 10 centimeter, it's a converging lens, it will only converge.
Converge.
So if a collimated beam passes through this lens, it will converge to a point. So
Yes.
next, this lens will be always forming a real image at a distance of 10 centimeter irrespective of the object location. So it's saying this lens will always forming a real image at a distance of 10 centimeter irrespective of an object location. Now we see whether it will form image always image at a 10 centimeter here.
No, that
No.
is not correct.
Yeah.
I feel.
Because a convergent lens can form real image at all the points from focus to, you can say, almost infinity.
Infinity, yes.
Okay. Yeah. So it depends on the object location. A converging lens can form an image from focus to infinity. And if the image should be formed at the focus, what should be the object position?
It should be like 10 centimeter away from the lens, like on the left side. The object should be 10 centimeter away from the lens. Maybe.
10 centimeter is what actually?
The distance from
Yeah,
the object to the lens.
yeah, that's okay. But you know that the focus of this lens is, or focal distance of this lens is
10 centimeter.
10 centimeter. That is mean, what is mean by that? If the parallel rays are coming,
Yes.
then it will focus at
At 10 centimeter
10
from the from the lens.
from the lens. So what kind of object will make parallel rays?
What kind of objects make parallel rays?
Yeah. Or if all the rays should come as parallel,
Yeah.
where should be the position of my object?
At like 10 centimeter away from the lens.
Yeah, let's see. I'm saying that this is my one surface. Let it be lens or anything. I'm saying there is a surface here. And I am going to place an object at a different distances. Okay.
Okay.
Now I am placing a object very near here. Just think only this top portion I am considering.
Yes.
Now you see that rays are reaching here. Ray can reach like this way. Ray can reach like this way, like this way. Okay.
Yes.
Whether these rays are parallel?
No, it's not.
It's not the parallel. Now I am going to keep this distance a little bit far. Now rays can reach like this way. Ray can same point I am taking. Which is more oblique? Nearby point is more oblique or the far away point is more oblique?
Oblique. I did not get the meaning of oblique.
Which is more slanted?
If it is like more diverged form.
Yeah. Which is
Yeah,
more
when it
diverged?
is far.
When it is far, it is more diverged, or when it is near, it is more diverged?
I think far.
When it is near.
You can see. Just see this point. I'm only thinking 2 point. Just think that is from here. A far away point. Which angle is small? This angle is small or this angle is small? Angle 1 is, 2 is small.
Yeah, the angle 1 is small.
Yeah. So when the object is far away, the angle is becoming smaller and smaller.
Okay.
So if you just think that if the rays are coming from the object should be parallel, where should be the location of your object?
Infinity.
Yeah, it should be very far. Means it should be infinity. So you already know that one. That's the thing. Actually, on the lectures, actually you may have seen that there are conjugate points. They are telling. So there is an object, then corresponding there is an image point. If you put an object at the image point, an image will be formed where the object was there. Similar way, now we can see that parallel rays will converge to a point called a focus. So if you put an object at a focus, it will make the image, means the rays which is coming from that object will be parallel. That means the image will be formed at infinite only. So if you want to get an image at focus, your object should be at the infinity, or it means it should be very far. Okay. So A lens can form an image at its focal point only when the object is at infinity. Okay. Next. This lens will always forming an image at a distance 10 centimeter respective of objective. So that's wrong. It can form only if an object placed at 20 centimeter away from this lens, then the lens will form an inverted image at 20 centimeter distance to the other side. Whether this is correct or wrong. Here now.
Actually, I have a doubt in a third option.
Yeah.
You said like to get a, I mean, focal length of 10 centimeter, it has to be the rays has to be in a like parallel,
Yes.
right? So in practical way, how it is possible to get the, because we are not keeping the object in infinity distance.
Yeah. So
So how is it possible to get all rays in a parallel this one?
so we will not get a parallel thing. But the thing is that we will not get the image at
10 centimeter.
yeah, we will not get image at 10 centimeter. Where will be our image? That is actually coming how the lens is forming images. I think you people are already knowing this one, but yeah, if you want, I can just tell that also.
Okay.
So there will be lenses like I'm drawing a lens. Hopefully, this will be like a lens, and there will be an optical axis. Okay, this is a convex lens. Here I can give different locations. What are the locations actually? To tell, one is actually the focus of the lens. Okay, that will represent as f. Then the double distance of the lens called 2f. Similar way, this side, the object side also I can kept f, and there's a 2f distance. And there are like distances like very far away and very near to the lens and other things. You people may be already knowing this one. So now we can see where we can put our images. There are different locations. This is called, we can say that this left side, left hand side we can call as a object side, and right hand side I am calling as a image side. It does not mean that image will always form at the right hand side, but just call it this thing as image side because I am observing at that side only. Okay, now we can see that. Okay, let us put our image at object at different distances. So we can put an image at very far away, means beyond 2f. I am keeping an object at beyond 2f. How we will trace a ray in this manner? How to get an image from this kind of thing? Actually, we know that different light rays are coming from this point. Like this way, lot of rays are coming. And we will know that after converging this lens, the light rays will be focused at a particular point, or it should be converged to a particular point. Not at exactly at the focal point, I'm saying. It's not at the focal point. These rays coming from a point should be converged to a particular point. Only at that position we will get a image. This is the condition for an image that you may have already seen in your first lecture. So at least to understand what is the location of the image, we want to trace at least two rays from particular point such that I can say where these particular two rays from a particular points are meeting, the image will be constructed at that point. So I am going to check only the point which is easier to trace. So I can check a particular ray which is coming parallel as the optical axis. So I am going to trace one ray. This is a parallel ray which is passes through optical axis of the lens. Then after, if the ray is a parallel, after reaching the lens, what happens to this ray?
That will be refracted,
And it will pass through.
pass through the lens, and it reaches the second surface of the lens.
Yeah, that after reaching the second surface of the lens also,
Again, it bends.
it bends and passes through the focus of the lens.
Yeah.
Okay. So after bending, the parallel ray will pass through the focus of the lens. Okay. Now there will be another ray. There will be multiple rays, but I am taking only one ray which is easier for me to draw. So there will be another ray which is passing through the optic center of the lens. What happens to a ray which is passed through the optic center of a lens? If the lens is a thin lens, the ray which is passes through an optic center of a lens will pass without undeviated, without any deviation. Sorry. So if we considering a ray which is passes through the optic center of the lens, sorry, I don't have scale to draw here. If it is passes through the optic center of the lens, it will go like this way. Okay. Now you can see that at a point these two rays are meeting. This is not at all for these two rays. This is for the whole rays which is coming from this particular point. So corresponding to that point, actually this point will be recreated. This is the fundamental of the imaging. So we can say that this is the point formed here. So we can create an image here. Now you can see that. Where is the image formed? If the object is beyond 2f, the image will be formed at a point between f and 2f. Okay, this is not at a point of f and is not at a point of 2f also. So it is passing through. If the object position is beyond 2f, it will be formed between f and 2f, and you can see that the ray is actually converging here. So the formed image will be real image, and you can see that image is inverted. So it will be a real image, it will be an inverted image, and size of the image also you can see. The size of the image is less comparing with your original object. So this is a real image formation by this lens. Now if you moved this lens, moved this object towards if you moved this object at 2f, what will happen? This parallel ray will move like this way only, but you can see that this is not the ray which is passes through this optical axis. In that case, it will go like this way. This my drawing is not good and is not at all scaled. If it is if the lens is 2f, this image will be will go and meet in such a way that this will cross at exactly at 2f, and it will be similar size as of the object. The image and the object size will be same in the case of a thin converging lens if the position of image at object at 2f, not f. And what happens if you move it towards, again, if you are moving between f and 2f, what will happen?
So the image is formed beyond the 2f.
Yeah,
In the RHS side.
Yeah, image will go beyond 2f. The size of the image will be,
so large.
Yeah, it will be larger, and it will be inverted, and it will be real. Okay, then if you put our image at focus, what will happen? No, sorry, object at focus, what will happen? Let's see, this is the focus of the lens. After this one, it will actually pass through focus, and this will also pass through optical axis. It will go, whether it will meet or not.
So not meet.
It will not at all meet. So we can say that it will go and meet at infinity. So
yes, sir.
So it is like if the object is such a focal point, the image will be formed at infinity. Similar way, in the other way, if the object is at infinity, image will be formed at the focus. So if the object is at the focus, image will be formed at infinity. Now you can see that what happens if I put my object much more near to the lens. Now we can see that it will go, will pass through the focus, but the ray which is passed through the optical axis will go, and it is like it is diverging. So we will feel that this is coming from a point which is from the same side of the lens, and we will feel that there is an object, some bigger object at the same side of the lens. If you are looking, actually there will not be a real image there. The whole image which is formed will be virtual only. But the thing is that you will feel, so actually if you are looking at this side, you will feel that there is a big image of that particular thing is here. So when you are observing a small object using a magnifying glass, you will keep always the object in such a way that it is between your focal length of the lens and the original lens. So it will be, you will get a bigger virtual image of your object which should be observed. These are the different position of imaging of a convex lens. So let us see that question. Now I think it will be clear. If an object is placed at 20 centimeter away from this lens, then the lens will form an inverted image at 20 centimeter distance on the other side. Whether it's correct or not?
Wrong.
Wrong. 20 centimeter means 2f.
27. Yes.
Yeah, 20 centimeter is 2f. So if it is 20 centimeter, it will also form an image at 20 centimeter. So the answer is correct.
Correct. Yeah.
Okay. Now, a ray of light travels from air to a rectangular glass slab of specific thickness. Considering it normal to the surface of incidence of the glass slab makes it 45 angle degree, and the refracting index of the glass is 1.5 degree. Which of the following statement is right, and the ray coming out of the glass slab? The ray will be bent away from that. Let's see what will happen. Now see, there is a glass slab. thickness is something, and I can draw a normal to the surface. Okay, and I am drawing a incident ray. Incident angle is defined as the angle between incident ray and the normal. So this will be the incident angle, that is given as a 45 degree. Now the question is that you have to choose what are the right answer. So before choosing, we can see that what will happen to this ray. What will happen to the ray when a ray travels from one medium to another medium having a refractive index difference?
So if the ray is traveling from rarer medium to other like higher medium, then it will be refracted, I mean, towards the normal.
Yeah. So which law states that one?
Snell's law.
Yeah, Snell's law states that n1 sine theta 1 is equal to n2 sine theta 2. Actually, this equation contains all the information. Okay.
Yes.
So according to Snell's law, we can say that if the refractive index is increasing, means from rarer medium to denser medium, what happens?
It will be refracted towards it bends towards the normal.
Yeah, it will bend towards the normal. So it will bend towards this normal. Okay. What will be this angle?
28.03 degree.
Yeah. If you calculate, how you will calculate? You have
Sir,
to calculate.
N1 to come.
Yeah. N1 sine theta 1, you have to calculate N2 sine theta 2. N1 will be 1 sine 45 degree equal to N2. N2 will be 1.5 sine theta 2. Sine theta 2, you don't know. So what you will do? So what is sine 45?
0.707.
Yeah, so then 45 1.1 by root 2 will be 0.707 is equal to 1.5 sine theta 2. So we will get sine theta 2 as 0.707 by 1.5. So we will get something 0.4714 or something we'll get. Okay. So theta 2 will be equal to sine inverse this 0.4714, corresponding you will get a 28.12 degree. So this angle will be 28.12 degree. Okay. Now that you got. Now you see what happens the ray after this one. This angle is 28.12 degree. What will be this angle?
28.12.
Yeah. This will be also be 28.12 degree. How this angle is coming 28.12? Anybody have that doubt? If nobody having doubt, then I can go. If everybody is agree that is 28.12, otherwise just tell. Or I can tell that these are like the basic mathematical thing. These are like a parallel one rays crossing a parallel ray. So these two kind of angles will be always equal. This angle and this angle. So this is 28.12. This will be also be 28.12. Okay. Then now it's coming the other side. Now we can see that now actually exactly the opposite kind of the situation is came. This is now we see that the sine theta 2 is 1.5. Now 1.5 sine theta 2 instead of that one. Now what will come here? Now if you want to calculate the angle here, so it will be 1.5 sine 28.12 equal to, outside is actually air. So 1 into sine theta O, I can say. What will come like this way. Sine 28.12 we already calculated. It will come as a
0.4714.
yeah, it will come as a 0.4714 and into multiplied by 1.5. So 1.5 into 0.4714, it will be like a, what will be value?
Sir, 0.7071.
0.707, that is 1 by root 2. So sine theta 0 will be equal to, implies theta 0 will be equal to 45 degree.
45 degree.
So what is actually the inference here? The angle of incidence here is 45 degree. This emerging angle also 45 degree. But whether they are in the same line, if you extended this incident angle ray, whether you will get in the same line or not.
They are parallel to each
Yeah, they are actually parallel to each other. There will be a offset which is coming from this incident line to that emerging line. So which option is correct here? You can see that there is the ray will be go the same direction of propagation and will go with a slight offset distance the transfer direction in the initial beam location. This will be the your correct answer. Okay. Now, so that's clear now. Now we can go for this next question. This will be also we already discussed. A thin converging lens has a focal length of 20 centimeter. If an object is placed at a distance of 20 centimeter, image will be formed at where? Focal length is 20 centimeter. If the object is placed at a distance of 20 centimeter means the object is placed at a focus. If the object is placed at a focus, where will be the image?
Sir, 10 centimeter.
Convergence of focal length of 20 centimeter. If the object is placed at a distance of 20 centimeter. Both the focal length and the distance is same. Means you place the object at a focus only. If the object is at a focus, where will be the image? If the object is at a 2f, you will get a image at a 2f. But if the object is at a focus or at f, where will be your image?
At infinity.
Yeah, the distance will be, means that image will be formed at a infinity. Okay.
Yeah.
Now see, consider a photo is taken using a wide angle underwater camera placed underwater, keeping the lens direction towards the water surface vertically up. Okay. If the water surface is stationary, what would be the nature of the image? This is it's not a tricky question, it's a nice question, but yeah, let us see how we'll understand this question. Now, what is the condition here? There is a water surface and there's a camera. We kept it here. You are taking a photo. Let this be a pond or something. There are trees here at the nearby. Something like that. Some buildings are here. Okay. You are taking a photo. How you will get the photo? That's a question. What will be the answer? Or how you are going to get the photo? Any idea? You people knowing refraction, na? Refraction you already see. Let's keep the camera down. Now, to get an image here, what is required? Light should be come here, correct? So let us think. What are the light will come here? Whether all light from all this surface will come here or not? That's my question. So we'll see that the light path can be retraced. So if the light is coming from here, it will bend. Actually, this is air, n is equal to 1. This is water, n is equal to almost 1.33. And it will bend and reach here. Correct?
Yes.
Similar way, the light from a building also can bend and reach here. Correct?
Yeah.
Yeah. Now we can see whether all light, a light from here can reach here.
From where?
From here. Whether now we are
Yes.
seeing that, yeah, here also one light can reach here also one light can reach here also one light can reach here. But here actually there is no light source.
Yes.
In this underwater there is no light source. Whatever the light is actually coming from outside only.
Yeah.
Okay. So now you see. Now just think that if I am retracing the path or I am taking the opposite side of the path, same thing, a light ray can retrace its path. Okay, if a light is coming from this direction to this direction, if I put a light ray from here also, it can go same direction. Okay,
Okay.
yeah. Then now think that whether you can put all light in every direction, whether you can put like this way, whether every light will go outside the water,
Yes.
whether it will go or not. There is a condition called total internal reflection.
Okay.
Yeah. When the angle of incident is more than the critical angle,
Critical angle.
yeah, the light will
Total internal reflection will happen.
totally reflected inside the same medium. Now you see, corresponding to this water and air interface, the critical angle is around the 48 degree. It will come. So whatever the light, just think that opposite manner. Okay, just think. We will come back to the original question now. Now think that instead of the camera, it's a light source. I am sending light from this source to everywhere. And in that case, what happens? If a light is coming here, it will bend
Yes.
away from the normal. If it's a little bit more, it will more bend. And at a particular angle, let it be this is the 48 degree angle. It will be like
Yeah.
exactly parallel to the surface.
Hmm.
If it is more than this one, it will not at all go in the other surface. It will totally reflect inside this surface only. Similar
Yes.
way, here also what will happen? It will totally reflect in this surface. It will reflect. Okay. So what happens in the opposite sense? If there is no light source inside this water, so there is no way light to come in this camera at this angle.
Hmm.
Okay, so in the other direction you will not get any ray from here. Similar way, here also you will not get any ray. You will only get rays from in a cone. Now this only two-dimensional I draw, but I can draw it like a three-dimensional, like it will be like a cone. But this whole cone containing all the light which is coming from outside. Here it will become, it will come here. Here also it will come here. Here also it will come here. Like that way, all outside thing will come inside your camera. But whether your camera's whole area will be illuminated or not, it will not be. Only this portion will be illuminated. That containing the whole outside information. So what kind of image you will get it? The photo will be like a circular portion containing all the images of these trees and other things, but all other portion will be dark. This will contain some tree information or some buildings you can see here, something like that you will see, but this entire portion will be dark only. You will see a circular portion which is illuminated and the outer surface are dark. Okay, understood? Hello.
This angle is also known as acceptance angle.
Whether this is called acceptance angle, I have doubted. I don't think it is. I don't think this angle may not be acceptance angle. I think it's a, if it is in the case of the optical fiber or something, I think it can be called as acceptance angle. But yeah,
In,
yeah,
in case of optical fiber, we call it acceptance angle.
yeah.
But
This is
in general case, do we call it, or is there it is termed something different?
that I am not at all sure whether we can call it as acceptance angle or not. If it's a particular term, we cannot call. But this is exactly the same thing actually.
Okay.
Yeah. But in the case of optical fiber, it is like the movement will be, it is, arrangement will be different. This is your core and this is your cladding, and this is the acceptance angle. Now, this condition is actually different, but I'm not at all sure whether this condition also whether can we call it as acceptance angle. If we can call, then there is not problem. But yeah, this is something similar only because above this one you cannot get any information from here. But yeah, there will be difference I think. But here you can see in this area you will get all the information of the outside world. The only the problem is that it is actually limited inside a circular area. But in the case of an optical fiber, actually there are more information about here, but that you cannot even put it inside your fiber. That is not because of this one. Here actually all information about your outside world is here.
Okay. But in that case also we can we the area we define is here the density difference is there similar way over there density difference is there from denser to rarer and defined area is similar so
but
it is called so or not.
but here you see, here actually our aim is to get it totally internally reflected here. So
Yes.
then only it will reach the other portion where your information is seek or information is taken. But here you can see, if the information is coming from this position or the light is coming from this position, it can undergo refraction here and it can leak out. So
Yes.
the information here will not at all pass through the fiber. But
Yes.
yeah, in this case you just check, there is no information is lost. Whatever the information in the entire world is coming here, only the thing is that the portion where you are getting information is very small, that only.
Okay.
Like this way there is no loss of information. I'm not sure this whether this angle is called acceptance angle or not. I'm not sure. That I can discuss, I can check and tell.
O- Okay, sir. But here the entire information we get on
Yes,
this small piece,
yeah.
but over there is a loss of
Yes,
attenuation.
yeah. After a particular angle, you cannot even pass that particular information through that fiber. So
Okay.
that may be different.
Okay. But we call it or not, that's a
Yeah,
doubt.
yeah. That I have to check whether this particular angle, whether you will call acceptance angle, we have to check. Okay. So this you can actually check. Just check in the Google like that way how a this underwater image is look like. You can exactly see that it will be look like a circular portion which is having a illuminated area and outside portion is a dark area. You can exactly see. These are like observable quantities. Okay.
Okay, sir. Thank you, sir.
Yeah. Now next thing. So this is clear. 1.5 meter, 1.75 meter tall person standing on a boat trying to catch fish using a high power laser gun. There's a fish at a certain depth underwater at a certain distance away from the boat. What should aim when he sees the fish from above in order to hit the fish correctly. Where should he aim? This is a nice question. It's a tricky question. I will tell. Tricky. So it's like a similar thing. There's a river, and there's a boat, and a person standing here and sees a fish at a certain distance. Now see, since it's at certain distance, so if the person is seeing a fish, how, whether, now see that what happens, a ray of light is coming from the fish. It will bend at the surface and reach the eye of the observer. Okay, so what the observer will think, whether we know that whether this light is bending at this surface, we can't understand now. We only see that some rays of light from the fish is coming towards our eye, so we will think that the fish is somewhere here. Okay, understood?
Yes.
So the question is that whether he should aim at where he is seeing the fish or at a distance which is a little bit lower or a little bit upper or something to catch the fish. He has a gun. Where he should aim, whether he should aim where he is seeing the fish or where he should aim in a little bit downside or where he should upside.
Right on the fish is not a correct answer,
Hmm.
but after that, uh,
Below.
Downside of the fish.
Yeah, that, yeah, the normal question of this one is like original answer means the normal answer is a how, just think that you are carrying a gun and you are aiming at the fish, you should aim where a little bit down, then only it will reach and hit the fish, correct? So normal case you should aim a little bit down such that it will hit the fish. Okay,
Yes.
Excuse me,
but
sir.
in normal case you have to
Hello,
aim. Hello, yeah,
sir.
yeah.
Sir, I have a question. Sir, fish is going forward or backward? What is the condition of the fish
That's
when
it.
we
Just
hit
just
the fish?
just think that it's not at all moving.
Fish is moving forward.
It's not at all moving. It's a freeze. It is there only.
Okay. Okay.
So you can in the case in the case of a normal thing, you can aim a little bit downside such that you will hit the fish. Okay. But here the answer is wrong. Here that answer is wrong. Why? That is why I am saying this question is a tricky. Trying to catch a fish using a just read this one.
high power laser gun.
High power what gun?
Laser gun.
Laser gun. What is coming from there? What will come from that gun? It is not a bullet is coming from the gun. What is coming from the gun?
Laser beam, a monochromatic wavelength.
Yeah. So what happens to that light when it is passes through this one? It will also bend now.
It will also bend hand.
So where should he aim? He should aim at the same location where he is seeing the fish, such that
Yes.
only,
Same,
yeah,
straight, only
yeah,
direct.
because that will bend and hit the fish. If you have a normal gun, you have to aim at a little bit lower side. But since
Yes.
it is a laser gun, you should aim exactly at the same position such that laser beam also will bend and hit the fish. Okay,
Yes.
so that's why that question is a tricky. Okay, next.
Sir, what's the answer?
So the answer is right on the fish.
Okay.
Okay,
Okay.
now we see. A laser beam of wavelength 632.8 nanometer is passing through a rectangular glass block of thickness 1 centimeter. If the refractive index of glass is 1.5, then the optical path length of the covered beam is how much centimeter? It's a simple question. You people are already seen this one. Means you know optical path length. So the question is simple. There is a glass slab and the laser beam is passing through this one. And they are asking what is the optical path length through this glass slab. What is the optical path length? How optical path length is defined? Optical path length is a product of distance and refractive index of the medium. Okay, n into d. So what is the distance here? Is given in the question that
1 centimeter.
1 centimeter. And what is the refractive index of that glass slab?
1.5.
1.5. So it will be 1.5 into 1 centimeter. Answer will be 1.5 centimeter. It's a fairly simpler question. Okay.
Yes.
Laser beam is gone. Yeah. Next. A person is standing 2 meters away from a mirror and he is trying to take a self portrait from the reflection of the mirror using a camera holding in his hand close to his body. In order to capture a good quality image, the focal length that should be set on the camera is dash meter. This just don't think about this focal length of the lens and other things. They just the question is only saying that asking that what should be the distance. That's the question. Okay, it is not like a focal length of the lens. It is like a to get a proper image what should be set in such a way that you just want to tell the camera that that object is this much distance. So they are asking how much distance is the object. This is the question. So this is the question. So one person is standing here holding a camera and there is a mirror. It's a very clear mirror and it's a normal mirror. It's a plain mirror. 2 meters away from the mirror and he's trying to take his self-portrait and he's the reflection of the mirror using a camera holding his hand close to his body. Now see, the distance is 2 meters. So the question is that where he will see that image, where will the image will be there? In a plain mirror, where will be the image formed? Where will you see the mirror image? In a plain mirror, the object distance and image distance will be exactly at the same distance.
Same.
Okay, so you will feel after this mirror there will be a 2 meter and you will see the images holding a camera and seeing like this way he'll see. So what is the total distance here? What's the total distance? 2 meter plus 2 meter will be 4 meter. So this person is the taking photo, and he is seeing. It's a clear mirror. He is not at all seeing the mirror at all. He is only seeing the person at a 4 meter. So you should set the distance 4 meter in such a way that to get a clear image of that same person. Okay. So the answer is 4 meter. Okay. Next question. In an optical system containing two lenses, for an object placed at a certain distance, the magnification provided by the lenses 1 and lens 2 is M1 and M2. The overall magnification of the output system is. What is the answer? How we can get the answer? So the question is like that way. I have a combination of the two lenses. I have combination of the two lenses, one having a magnification of M1 and another having a magnification of M2. The question is that what would be the combined magnification? For just to see that one, now let us see that how the combination of the two lenses work. Okay, you already see this one now in the second lecture. I think you see that how a refraction through a lens is formed. From refraction from a spherical surface, you arrived at an equation of a lens maker's equation as well as lenses equation. You reached now.
Yes, yes.
Yeah. For in the case of a refraction from a spherical surface, you took only one surface and it is forming an image. Then you reach at a condition in such a way that the image formed by the first surface is became the image formed by object of the second surface. And like that way you reach that lens equation. Correct?
Yes.
Now the similar way we are going to get a expression for a combination of the two thin lenses. Okay, just think that only one lens is there, only lens 1. This L1 is there. L1 is having a focal length of f1 and L2 having a focal length of f2, and I placed a object here and I am getting a image somewhere here, something like this. Okay, now what is really happening here? Now I am having a distance, some u here, and I am getting a v here. This is the combination we know. Now you see what is happening, really happening here. The image is actually formed by first L1. So in that case, we are not at all seeing the image formed by L1. So actually, this lens may be forming an image somewhere. We don't know. It's like a some arbitrary image I am drawing. So this lens is forming some image somewhere. This is not at all a particular point. Don't think this as a particular point. But let's see that it is forming a virtual or some image only because of the L1. Some image is formed. Okay. And that distance I am calling it as a V1. Okay. So according to the lens equation, 1 by u plus 1 by v is equal to 1 by f. For only for the first lens, I can say that u is proper u only. 1 by u plus only considering the lens 1, this is the v1. This is the image formed by the lens 1. Okay. So 1 by v1 equal to 1 by f1. Okay. This is only the equation for the lens 1. Now you see that this lens, the first lens's image is acting as the second lens's objective, and the image is formed at the normal imaging condition. So we can consider, if you want to take it as a u1 or u2, I will take it as u2, same u2. This is the object distance of u2, and this is the image distance. For the second lens, I can say that 1 by u2 plus 1 by v equal to 1 by f2. Okay. Any doubt in this one? Okay. I'm thinking no doubt is there. In that case, these are two equations, 1 and 2. Now you see, what is the difference between v1 and u2? v1 and u2 are the same distance, but in the case of the first lens, it is a image formed by the lens 1. In the second lens, this is actually the object of the lens 2. In that case, what happens? There is a sign convention happens there. So your u2 and v1, if you are considering only the absolute distances, that will be same, but there is a sign convention here, sign change in the case of u2 and v1. So we can change that equation as 1 by u plus 1 by v1 is equal to 1 by f1. Similarly, this equation u2 I am changing to minus v1. So 1 by minus v1, sorry, minus v1 plus 1 by v is equal to 1 by f2. So if you add these two together, what will happen? If I am adding that two equations together, what I will get? I am going to get a 1 by u plus 1 by v1 plus minus 1 by v1 plus 1 by v is equal to 1 by f1 plus 1 by f2. This 1 by v1 and minus 1 by v1 is gone. So 1 by u plus 1 by v is equal to 1 by f1 plus 1 by f2. This is actually the equation of a combination of two thin lenses. Now see what's happened. 1 by u is the object distance from the combination of the two lenses. 1 by v is the image distance from that. Whether it's exactly looking like a thin lens equation, 1 by u plus 1 by v. But instead of 1 by f, it is what is the 1 by f1 plus 1 by f2. So I can call it as a 1 by f, where f is a combined focal length of the two lenses. So in that case, I can say that in the case of a combination of the two lenses, what happens? The combined focal length will be 1 by f will be 1 by f1 plus 1 by f2. Correct? Any doubt? Now see, what is 1 by f? 1 by focal length. What is the 1 by focal length? It's called a,
Power.
yeah. So I can say that it is the combined power. combined power of a lens is equal to 1 by f1 will be what is the 1 by f1? It's the
1 by
power.
P1.
Yeah, 1 by f1 will be p1, means the power of the first lens, plus 1 by f2 will be power of a
P2.
p2, power of second lens. This also we will arrive from this equation. If two lenses are putting together, the power of the lenses will be added, or the reciprocal of the combined focal length will be equal to the sum of the reciprocals of the focal length of the each lenses. Okay,
Yes.
these are the two things which is happening in the combination of the two lenses. One more thing you can see here. What is actually magnification of the lens means? V by u, correct na? Minus v by u, you will call that as magnification. Correct? M magnification, I can say that minus v by u. Okay, so I am doing one thing. I am just multiplying top and bottom with the same number. What number? Minus v by u into top and bottom. I am multiplying with v1. Top also I am multiplying with v1. Bottom also multiplying with v1. It will be same only now. There is no
Yes.
difference. And now I am just rewriting this one. Minus into v by v1 into v1 by u. Okay, and I'm putting like one minus here also, one minus here also I'm putting here. It will be same only now. There is no difference here. It is exactly same as minus v by u now. Minus v by v1, v1 will cancel. This minus 1 will be cancelled. Exactly same.
By V. Yes.
Okay, now you see what is this minus v by v1 on this image. Minus v by v is the image distance of the second lens. What is v1? v1 is actually the object distance of the second one.
Yes.
This was v1 na?
Yes.
So it was object distance of the second lens. So what you are getting here, this portion is actually what? M2, magnification of the second lens. Correct?
Yes. Yes.
Uh,
M2, and that is
uh,
into M1.
and here you see there is a sign convention here. So whatever you are getting here is a minus of the m1. So here actually it should be u2, minus v by u2. Minus v1 is actually what? One minute. M is equal to minus v by u is equal to, and I am arriving here, minus I put it here, p by minus v1 into minus v1 by u. Okay, okay, correct. Now we see minus v by minus v1. Minus v1 is actually our u2. This is the same thing as u2. Okay, so we can put it as minus, this will be v by u2 into minus v1 by u. Okay, now we can take it out. See, it should be like a minus v by u2 into minus v1 by u. Okay, what is minus v by u2?
M2.
Yeah, m2 into minus v1 by u. What is that term? Minus v1 by u will be m1. So the combined magnification will be the product of magnification of the single elements. Okay, so these are the three things which is important for the combination of the lens. 1 by f will be equal to 1 by f1 plus 1 by f2, or p will be equal to p1 plus p2, or m will be equal to m1 into m2. These three things are properties of the combination of two thin lenses. Okay, so here what is the answer? In an optical system containing two lenses for an object placed at a certain distances, the magnification provided by lens 1 and lens 2 are m1 and m2 respectively. Overall magnification will be, answer will be first option, m1 into m2. Okay, the magnifying glass used to see object is bigger using a lens. If f is the focal length of the lens as used as a magnifying glass, which of the following statement is true? So already we told, when we are seeing an object through a magnifying glass, the position of a object should be equal to, where should be position? To get a bigger virtual image at the same side of the object, where should be the position of the object or position of the lens? We adjust that object will be at what distance? Hello? Okay, I can tell answer. So in that case, the lens should be a concave lens. So it's a converging lens used, and the object should be kept in between the lens and its focal length. So the answer is 4. It should be converging lens is used, and the object is kept between 0 and focal distance of the lens. Okay, these are the answers. But in between the answer, actually we discussed a lot of things. And the thing is that I already see assignment 1 and 2, and these informations are actually sufficient to solve all the assignments. Okay, so if you have any doubt, you can ask.